As a reaction, it must apply some frictional force to this reaction. So this is action and reaction, these two forces. Can you see that? And of course, if this frictional force is pulling object to that direction, to balance that force, then this surface has to provide some frictional force in the opposite direction. So this frictional force will cancel this frictional force. Okay, and so what you have here, the situation is that you can see block 1 and 2, they are not moving. For block 1, the reason is that the frictional force cancels the external pulling. And for block 2, because the two frictional forces cancel each other. Okay? So start to think about this more complicated situation when you have two objects. Okay? Both of them principally can move. And when we start more and more, especially in University Physics 1, 24, 25, okay, we will definitely have this more complicated situation. Any question here for these frictional forces? Okay. So most important is try to understand this frictional force, how it comes. Another way to think about it is that when you try to pull the object 1 to the right, okay, so that means object 2 has a tendency of relative motion to the left compared with object 1. Okay. Okay, do I have any questions? So now, let's look at another example. Okay, if you still remember what we discussed for the last class, okay, this should be straightforward problem. A block is at rest on the horizontal surface. The maximum static friction for frictional force is 50 Newton. What is the static frictional force if you pull it horizontally with the 30 Newton force and the 60 Newton force? Okay. So for A, what is the frictional force? Fs, if you pull it with 30 Newton. Okay. Anything else? Do you have any other answer? For A, 30. Okay. Any other answer? 80. Okay. It seems that we try to combine these problems, give me all the possibilities. Okay. Anything else? Maybe 50. Okay. We kind of run out all these combinations. Okay. So which one is correct? If you vote A, B, C, D, 1, 2, 3, 4, which one is correct? This one? No, I'm asking you, how many would choose 1? How many of you would choose 2? Okay. How many of you choose C? 3. How many of you would choose this one? Okay, most of you choose this, and several choose this, and some others choose this. Okay, but the correct answer, let me take a look. Okay, the correct answer is okay. And remember, okay, so first let's see what happens if we have this. Most of you choose this, okay? What happens if you have this? Okay, if this is true, you can see what happens. Now, I'm pulling with 30 Newton. And then you say you have frictional force of 50 Newton. So the object will move to that direction. So you are putting object in this way, and the object will move to that direction. So that's what your answer 50 Newton tells us. Okay. So that's a key issue about the static frictional force. The static frictional force actually is, okay, you can think about the system is quite smart. It will give you the frictional force in terms of the external pulling force. It will just match your external pulling force unless it cannot match it anymore. Okay. So if you try to pull the object with 30 Newton, and this object will try to respond to you with exactly 30 Newton frictional force. It's enough to prevent the motion, and that's it. It wouldn't bother to give you 31 Newton, right? Okay. So, it's 30. And by the way, of course, I don't know why 20 and 80. B, let's see. 50. Okay, this one, someone said 50. Do you have any other answers? Okay, someone says 60. Anything else? Okay, the right answer is 50. Okay, what's wrong with the 60 is that, yes, the system tried to give you 60 Newton frictional force, but he cannot do that, right? Because the maximum static frictional force can only be 50. So even the block would like to, but he cannot give you 60 Newton static frictional force. Okay. So he will try his best. When you pull it with 60 Newton forces, he will try his best to give you 50 Newton frictional force. Okay. Of course, this is not enough to prevent the motion. So if you use the 60 Newton force to pull the object, then it will start to move. Okay? Okay, so you can try to think about this as some people, right? Very kind people. Like I have 50 bucks, and you ask me to give you some money, okay? So if I'm kind enough, I will give you whatever you ask. 20, if you ask 20 bucks, I will give you. If you have 30 bucks, I will give you. But if you ask 60 bucks, I have only 50. So I can only give you 50, right? So this is what happens with the frictional force. And in terms of the standard procedure, okay, you can do something like this. You first, you have to compare the external force F and the maximum static frictional force. Okay. In the first case, external force is 30 Newton. This is 50 Newton. So if F is smaller than the Fs max, so static frictional force is equal to F equals to 30 Newton. If F is greater than Sm max, okay, in the part B, this is 50, this is 60, then Fs equals to Fs max equals to 50. Or in other words, the actual static frictional force is determined by the smaller one of the two. Okay. Any question here?